Hello, in this video we will talk about one kind of non-parametric statistics. It is called signed rank test. So we know non-parametric statistics is an alternative to traditional statistics test. And because in statistical testing processes like t-test, chi-square test, or f-test, we assume that random data come from normal populations. But sometimes this assumption cannot be met. So we can use, for example, non-parametric statistics because these kind of statistical tests not assume data coming from normal. So say these kind of procedures are statistical distribution free tests. And the signed rank test gets the information both for the sign and the rank from the data. For example, if we want to test the null hypothesis that mu hat equals this mu zero hat. So here mu hat is the median of the data, median of the population. So we get the data from this population and we will test if the median of the population equal to a pre-specified value. Then we can subtract all the sample with this data, with this value. And we get the difference for each sample, right? Then the difference can be ranked according to their absolute value. So absolute difference we get, and we rank these absolute differences with the lowest value is the 1 and next is 2 and so on. For example, we get 10 sample data and we subtract each of them with this mu zero hat. Then we get 10 difference, right? And we get also the absolute value from this 10 difference. Then we rank them from the lowest to the highest, from 1 to 10. But sometimes you may have the difference, the absolute value are the same. In this case, we can rank them with the average value of the rank. For example, we have 5th and 6th absolute differences are equal. Then we rank them, each of them with 5.5 because their rank total is 11. So we rank them 5.5. If we have 3, then we can divide the rank of the total by 3 for each of them. So this is quite simple. So after these procedures, we can test if this hypothesis is true, or we will reject it if it is not seems true. So we get the ranking data, right? Then from the negative difference and from the positive difference ranking data, we will assign them to the total in W plus and W minus. So we get absolute value to 10. Maybe 3 absolute difference coming from the positive. Positive means the sample is larger than this value, right? And the other 7 absolute difference value coming from other 7 sample, because other 7 samples are less than this value. Although their absolute value is positive, but they come from the samples that are less than this value. So we divide the total rank in 2 parts, one coming from the positive part and one coming from negative part. So positive part means these samples are larger than this value, and the negative part of the rank means their samples are less than this value. So now it's quite clear. So next we will test this hypothesis if 1 second. We also get the smallest of these 2. So maybe they are the same, but in 99% of the case they are not the same, right? So So they have a smaller one. So we assign this smaller one called W. So this W is what we will focus on. We'll test if this W is very small. If this W is very small, we will reject the hypothesis of they are equal, right? Because if they are equal, it is true, these two ranking data will almost be very close, right? So if W is relatively very small, we will reject this hypothesis and in favor of the alternative that the population median is less than this value. And on the other side, if W is this negative side of the ranking is very small, we will in favor of the alternative such that the population median will be larger than this value, right? Sorry. And in practice, there is a table will show approximate critical value of W plus or W minus. So either of these is for the lowest value. If either of these, the smallest W is less than this critical value in the table, then we will reject our hypothesis that these are true, right? And the table will show different significance level and one-tailed test or two-tailed test. Now this is the table. For example, we have 10 samples. For one side of the test, alpha is 0.025. If the smallest of the ranking, either coming from positive side or negative side, less than this number, then we will reject the hypothesis that the population equals this value. So next we will show an example. So data represent the number of hours thought operates, and using the signed rank test to test the hypothesis at 0.05 level of significance, such this number's median equal to 1.8 hours. So we establish the hypothesis. H0 is population median equals 1.8, and alternative hypothesis is this population median not equals to 1.8, and significance level 0.05, and the critical region here, because n is 10 after discarding one measurement that equals 1.8, so there are 10 observations left, and the table shows the critical region to be less than 8. Next, we will compute by subtracting 1.8 from each measurement and rank the difference without regard to sign, because here is, you can see this 5th and 6th ranking, so we average them 5.5, and same for this 3 has same rank, then we divide them as 3 or 3. So this is all the rank. You can see some from the positive side and more from the negative side. So we collect them, each of them, into positive side and negative side's rank. So because the smallest one is positive side, so we use this value to compare with the critical value from the table. You can see because this value is larger than 8, so here we do not reject H0 and conclude that the median operating time is not significantly different from 1.8 hour. Thanks for watching.